Thank you, Peter, for that very generous introduction. Thanks all of you for being here, and thanks for the invitation to meet the minds behind SPM and FSL. This was a very unique opportunity, so I appreciate that very much. We've talked a lot in the past day and a half about different applications of these software packages, different methods that are being published now. And an undercurrent is that we want all of these to be hopefully reliable, predictable, and robust. This is a figure I'm sure most of you have seen. This was published back in 2015 by the Open Science Collaboration, of which Brian Nozick is a co-founder. And this was published in Science. It got a lot of widespread press. And the idea behind it was to take 100 different experiments, social psychology, cognitive psychology, and then have independent teams of researchers try to replicate those results. A small point of difference between words like reproducible and replicable. Reproducible means you use the exact same data, exact same scripts, and ideally you get the same result. Replication is where you use a similar data set, a similar experiment, and get more or less the same effect that they do. So replication is really, should be common currency in the field of science. However, what they saw was out of the 100 that they collected, only about 39 of them were replicated at the p less than 0.05 level. And this, obviously, we have similar issues in neuroimaging as well. We've seen with work from, say, Tom Nichols, that even small changes in things like processing pipeline or versions can lead to different results. Now, over the years, there's been the so-called big three. There's a tennis analogy here, just like Federer, Nadal, Djokovic. These packages like SPM, FSL, and AFNI have dominated the field for years and going into decades. Now, all three of these more or less do the same thing. They've all been developed to analyze neuroimaging data, usually fMRI. There might be different emphases for someone who's first coming to these different packages. SPM has a very clean, streamlined graphical user interface, and indeed I use it for newcomers because I think it's an excellent pedagogical tool. It's very accessible and easy to pick up. Other packages like AFNI, FSL, a little bit more command line driven, more emphasis on that. But in any case, whatever they're built on, MATLAB, Python, R, eventually you try to get from the pre-processing to results and some kind of interpretable figure. So that's not to say that things like FSL and AFNI don't have a graphical user interface. They do, obviously. It's not to say that you can't script or use the command line with SPM. You can. It's just the person's first point of contact. They might have different emphases. And all these packages obviously have widespread support and training courses. Now, more recently, there's been a very dramatic increase in the use of Python. We've seen packages like NiPype, NiLearn. These obviously are based on Python. In the past about 10 to 15 years, Python, its use has taken off dramatically. So this is a graph based on things like how often these programming languages are searched for with Google, other search engines, also how often they're used in publications, and so on. And again, starting around 2014, 2015, you do see Python start to dominate the market share, where now it's used by about roughly 24, 25% of programmers worldwide. And I would argue there are many different factors that are self-reinforcing that have led to this, and which today's neuroimager should be aware of. One was the development of Jupyter notebooks back in 2014. So you can see there was a pretty dramatic uptick around then. I don't think that's a coincidence. And Jupyter notebooks have made it very easy, one, to program in Python, and two, make your code transportable and transparent across different groups. It's a web-based programming interface. It's divided into sections of code that can be called cells, so that a new user, if they don't know anything about programming, they can't cause too much damage if you restrict them to one cell, but these can be daisy-chained together to produce an entire script. And lastly, they're easy to share, especially on GitHub and other websites, which I'll demonstrate in just a few moments. So here's what a typical Jupyter notebook might look like. So there's a markdown language. On the right, you have the raw data, the raw programming. And then on the left is how this gets transformed into different figures, different formulas, symbols, and so on. It looks very clean. Again, very easy to read and easy to execute. And it's interactive. Another concurrent trend is virtual environments, and these have been around for a while. It's nothing too new, but there have been many instances where these become much more sophisticated and specifically much more helpful for neuroimaging analysis. So for example, with Python, you might specify a certain virtual environment, you give it the name, and then within that virtual environment, you could install different software packages and different versions. So you would, within this so-called sandbox, it would be isolated from the rest of your local machine so that you wouldn't have to worry about different path conflicts or different software versions interfering with each other, which makes it much more, again, robust and reliable when you program within that environment. One of the major developments recently, this was published last year in Nature Neuroscience by Angela Renton and colleagues. This is a group out of the University of Queensland in Australia. And I saw this last year, and really this answered a lot of questions that I've had for a long time and hadn't really been able to formulate. What NeuroDesk is a container. So think of it, it's not the same thing as a virtual environment or a virtual machine, but it has some similar concepts. The container has a certain software package and all of its dependencies. So for example, the Con toolbox, it requires MATLAB and it requires SPM. Within NeuroDesk, you can simply click Con, any version that you want, and it will have all the prerequisites such as MATLAB and SPM to run that. In addition to virtually any other modality you can think of, EEG, ASL, fMRI, obviously, diffusion-weighted imaging, and so on. And these can be run either as a local container on your machine installed using Docker, or you can do something called the play function, in which you can access it directly through a web browser. To showcase how this aids things like reproducibility and robustness, they analyzed the same data set using the same pipeline, but on two separate machines. One was using one version of Linux, the other one maybe was Macintosh, something like that. But the point was, it shouldn't matter what operating system you're using. Windows, Macintosh, Linux, we would hope that if I gave you the same script I used to analyze my data, you would get the exact same result. What they found, if you look in panel A, they used FSL to do co-registration between one anatomical data set and a template, and then also used FSFast to do segmentation of the thalamus and subcortical structures. What they found was there are some differences between these two operating systems we're looking at that did not use NeuroDesk, but if you ran the same script within NeuroDesk, there's virtually no difference between them for co-registration and very minimal differences during segmentation. For the next few minutes, I'll be showing you a short video, just a couple slides to get you oriented. So once you download NeuroDesk, again, here is a sampling of the different programs that you can download. So for example, electrophysiology, diffusion imaging. Within fMRI, you have AFNI, FSL, SPM, and different versions as well. SPM 25 is not available yet, but it will be very soon. And then within NeuroDesk, you have access to Jupyter notebooks. Again, you can either analyze your data the exact same way you would within the virtual environment, or you could use the Jupyter notebooks as a kind of wrapper to call upon different commands from, say, FSL or TBSS or SPM, as the case may be. And within these Jupyter notebooks, you can display the data if you want. There are many options here. You have NeView, you have IPython, or if you want, you could just take the results, put it back to your local machine, and use whatever viewer that you want. So here's a short video. I may be skipping around. But here I already have NeuroDesk installed through Docker. You open up an instance of NeuroDesk. It takes a short while to load. And once it opens, you'll have access to something called the launcher, in which case you can simply load up NeuroDesk, which will install this virtual environment that looks like another desktop within your desktop. So we're going to open that here. Open up a desktop, doesn't matter which one. You can make it dynamic, you can make it the same resolution, really up to you. And then within this, if you open up Neurodesk, I hope this is not too small of text, but for example, you can see hippocampal segmentation, EEG. Within the functional MRI section, you have AFNI, many different versions going back at least a few years, FSL, SPM. For this demonstration, I'm just going to pick AFNI because I know it loads the quickest. There's no bias here. I don't want hisses, boos. I don't know what the feeling is about AFNI. I'm really indifferent to the packages. I think they're all very well developed and supported. But here you can see just through a click, I loaded AFNI. I'm just showing you one of the commands. The help file loads with no problems. And within this environment, you can load up the graphical user interface. So again, you don't need to change anything. It simply makes it more robust. And whatever you do in this environment, I can be sure that if I gave you the same script, it would run the exact same way on your computer, regardless of what you're using. Now, the last section of this video demonstration is to show you within Jupyter Notebooks what it would look like. So here's just a sample Jupyter Notebook. You can open it up, start coding, whatever you want. But more to the point, I want to show how something like Neurodesk and Jupyter Notebooks makes science much more reproducible and robust. So here within GitHub, this is Neurodesk's GitHub. Within their repositories, there's a series of different Jupyter Notebooks you can use to demonstrate different modalities and how to pre-process and analyze them. For example, there's example notebooks, and within example notebooks, I've been collaborating with the developers to translate my online tutorials into these Jupyter Notebooks that you can then run within Neurodesk. Just for a demonstration within diffusion, we have a series for TDSS and also for MR tricks. And if, for example, I download one of these Jupyter Notebooks, very easy to do. And let's say it goes to my downloads directory. When you install Neurodesk, you have a directory that will be installed by default called Neuro Desktop Storage that acts as a portal between Neurodesk and your local machine. So you could click and drag files from your local machine into Neurodesk, or conversely, do the analyses in Neurodesk. Once you get the finished product or any intermediate stage, you can then bring it back to your local machine if you want. So here, I'm simply opening up that Jupyter Notebook that I downloaded. I'm not going to run all the cells, obviously. I'm just going to do a subset to give you a flavor of what it can do. But notice here we have some expository text. Where does this come from? What's it going to do? Again, very useful for pedagogical purposes. And then here you can see we can install some different modules using pip. And then we get to loading the actual neuroimaging software. So again, whatever version of MRTrix, whatever version of FSL, and this makes it very easy to replicate somebody else's results that you may have seen in a paper. They provide you the data set, they provide you the versions, you can simply replicate it here. And I'm showing how to use Data Lab to download a sample data set from OpenNeuro. So again, this is kind of reinforcing an ecosystem in which people upload their data to an open access repository. You can easily download it and then start to run the analyses. I'm not going to run any more of these code blocks because they will take quite a bit of time, but just to scroll through a few more sample parts of it, you can start to see where, for example, we can display some of the data for intermediate stages, doing quality checking before and after, and making sure everything is working. So to summarize, the benefits of Neurodesk is easy to install. And again, I'm giving anecdotes, but I do think they're very illustrative because I've been teaching workshops and I've been teaching students for quite a long time. I tell you, there's no worse feeling than starting a workshop, somebody raises their hand and says, it's not working. There's an error. And you have to break the rhythm, help them out, and it really just, it's inefficient, nobody likes it. Last year, I was giving a workshop at Vanderbilt with 80 attendees. So let's say roughly the size of this room. And this is my first try at having everybody just install Neurodesk. And we were using FSL, we were also using MATLAB, and also Jupyter Notebooks over the course of this 2-day workshop. So we're touching a bunch of different platforms, programming languages, software packages. There were 0 installation issues. The template scripts that I gave them, no problems running them, no errors. That has never happened to me before, and I've been doing this for over a decade. So make of that what you will. Try it yourself if you don't believe me, but I do think that it is quite robust and quite transparent. In addition to that, as I mentioned with reproducibility issues, this makes it much easier to make sure that your results can be replicated and reproduced easily by anybody else, no matter their background or their neuroimaging software package. And I just want to reemphasize the compatibility across operating systems. So if you like Windows, Macintosh, Linux, continue using it. You don't have to change anything. Just download the appropriate version of Neurodesk and you should be okay. Then the last slide is the future, and predictions are great because nobody will remember in 5 years, let alone 5 days. Who knows, but I can make whatever predictions I want. But I do believe that in the next, let's say 5 to 10 years, virtual environments and containers like Neurodesk are going to be more widely used, both for the purposes of reproducibility and also for teaching. This will make it also easier to pre-register. It'll make it easier to share code and hopefully ameliorate the reproducibility problem. And lastly, virtual environments are going to enhance software such as SPM25 that have already been developed. If you like it, you can keep using it. It's not less, it's more. So lastly, thank you to the team from Queensland. This is Stefan Bohlman, his team, Ashley Stewart. All of them have done excellent work. And I believe that they're going to be continue maintaining this at a high level for years to come and hopefully become a going concern. And lastly, thank you to the SPM team. I really appreciate, and I know how difficult it is to organize something like this. And I think I speak for all of us when I say that we really appreciate your hard work. So thank you.